Today we talk about applications of rational equations, and the first type of problem we're going to deal with is a work problem. In this problem we have Tom mowing a lawn in 4 hours, Parker mows that same lawn in 5 hours, and we want to know how long it'll take for them to work together to finish mowing that lawn. The key thing in this is understanding what work rate means, and in this case Tom does his job in 4 hours, which means that in 1 hour Tom mows 1/4 the lawn. That's an example of a work rate. So he does really 1/4 of the whole job in an hour. In 2 hours he'd do 2/4 of the job, 3 hours 3/4, and in 4 hours he'd do 4/4 of the job, or he'd finish the entire job, representing 1. So what I do in all these types of problems is I set up a chart and divide it in 3. We've got Tom in this case and Parker, and what I do is I put the work rate in my first column, and Tom's work rate is 1/4 of the job per hour, and Parker's work rate is 1/5 of the job per hour. Then I need to know the time worked, because as I stated earlier, if Tom works for 2 hours, he's done half the job. And then if Parker works for 2 hours, he's done 2/5 the job, which isn't quite a half. Therefore, they haven't finished the job. So I don't know in this case how long they've worked together. That's the problem, actually. How long does it take? But I know they start at the same time and finish at the same time, so I'm going to call that X. And in our final column, we take total work done. And in order to get that, we multiply these two quantities together. As I stated before, work 1 hour, do 1/4 of the job, 2 hours, 2/4, 3 hours, 3/4, 4 hours, 4/4. Multiplying across, we get x over 4 and x over 5. And then if we add their two amounts of work done, x over 4 and x over 5, we want to know when they complete the whole job, which is represented by the number 1. So now this is just a rational equation. We can solve by getting the LCD of 20 to both sides. This gives me 5x and 4x equals 20. So we end up with 9x equaling 20, and x equals what, 2 2/9. Similar problem, we've got Devin and his brother Justin on a paper route. Set up my same chart. We put in our work rate, time worked, work done. Alright, and it says Justin can do his route in 45 minutes, so that automatically gives me his work rate. He does 1/45 of the job per minute. When his brother helps, it takes him only 18 minutes. Now this is a change from the last problem, because it tells us how long it took them working together. And they want to know how long it takes Justin to do the job alone, which means since I don't know how long it takes him to do the job by himself, I don't really know his work rate. I do know it takes him X amount of hours to finish the job, so I can say then his work rate is 1 over X of the job. And then I know they complete the whole job working together in 18 minutes. So I'm going to make my time 18 minutes. And if I now multiply, so I have 18 over 45 and 18 over x, I know that in those 18 minutes they'll finish the job. So I take and say 18 over 45 plus 18 over x is equal to 1. 18 over 45 reduces because 9 goes into both of those, so that's 2 over 5, and 18 over x is equal to 1. Multiply both sides by the LCD of 5x. We end up with 2x in this case. The x is reduced in this case. 5 times 18 is 90, and I end up with 5x over here. Bring the 2x over. It's 3x is equal to 90. So x in this case is 30 minutes, right? So in our next problem, it says you've got Janice who can do a quilt in 7 days, and then after working on the quilt for 2 days, she's joined by somebody else. Again, that's a change from our last problem. And they finish the job in 3 more days, and we want to know how long it takes this new person to finish the job alone. So that's a little bit the same as the last problem. So we've got Janice, we've got Trish, and we have the rate, the time, and the work done. So it says Janice can make that quilt in 7 days. So we have her work rate right there of 1/7. And then after working on the quilt for 2 days, Janice is joined by Trish. Alright, doesn't tell us anything about Trish working alone. They finish in 3 more days, and how long will it take Trish to make the quilt alone? So again, we don't have the time it takes for Trish to do the job alone, so we have her work rate of 1 over x, just like in the last problem. Trish in this case does 1 over x of the job for 3 days. And Janice actually works more than 3 days because she's already started 2 days ahead of time, so her time is 5 days. And then they'll finish the job after all that time has transpired. So we multiply across, we get 5/7 for Janice, 3 over x for Trish, add the 2 up, 5/7 plus 3 over x is equal to the whole job being done. LCD is 7x. Multiply through, that's 5x plus 21 is equal to 7x. Bring the 5 over, gives us a 2x is equal to 21. 21. Divide that through. 10.5 is equal to x. So we know that Trish alone would do the job in 10.5 days. Alright, so now we're back to distance, rate times time, and we've done these several times, but this may end up being a little bit different just because in the past we haven't done these as rational equations. So let's set our chart up. Distance equals rate times time, and it said a train travels 150 kilometers in the same amount of time that the freight travels 100 kilometers. The average speed of the freight train is 20 less than that of the express train, and we want to find the speed of each train. So in this case they're actually giving us a couple of distances, so I can put express train, freight train, and I can write in their distances. They give us 150, they give us 100, right? And they say the average speed of the freight train is 20 miles an hour less, so that's x minus 20 and x. Now, as we've done earlier in the year, Once we get two boxes filled in, we use the equation to calculate the third box. So if I know distance equals rate times time, then I know distance over rate is equal to time. It's like a literal equation. So I know 150 over x is equal to the time for the express train, and 100 over x minus 20 is equal to the time for the freight train. Now what I have to do is I have to write an equation relating the times, and if I read this first sentence, it's going to give me a little heads up here. So I have an express train travels at 150 kilometers in the same amount of time. Freight train takes to travel 100. So that tells me right there that the two times are equal. So I'm going to set those times equal and solve that equation for x. Do a cross product since that's a proportion. I have 100 x equals 150 x minus 3000. I can subtract the 150, giving me negative 50. X is equal to negative 3000. And then I would just go ahead and divide 3000 by 50, and I end up with 60. And that will give me the express train. And 20 less than that is the freight train. And I'm done. Let's do another one. And we've got Noah, who's a pilot, takes 2/3 as much time to travel 450 miles with a tailwind. That's going to be important. We've dealt with tailwind and headwind problems before, as it takes to travel the same distance against the wind. And if the speed of the plane in still air is 200 miles per hour, find the wind speed. Alright, so this is a headwind tailwind problem, which is also going to bring a couple variables possibly into this problem. May not, but we'll take a look at it. And we've got Noah here, or let's do headwind, tailwind. And again, distance equals rate times time. And it says he travels 450 kilometers, so, and that's with the tailwind, as it takes to travel the same distance, so we're going 450 again against the wind, and we know the plane speed in still air is 200 miles per hour, but then we've got this wind either opposing us or helping us. So the rate in this case is made up of two things: the still air rate and the headwind, and the still air rate and the tailwind. With the tailwind, we're getting speed. It's adding. So I'll call that W for wind. But with the headwind, we're taking away from our normal rate. Once again, distance over rate's equal to time, so that's 450 over 200 minus W, and then we have 450 over 200 plus W. And then now we need a relationship for the time, and it says it takes Noah 2/3 as much time to travel 450 kilometers with the tailwind than it does to travel against the wind. So if I multiply the headwind by 2/3, I get the tailwind. So headwind times 2/3 equals tailwind, and that's time. So I take 2/3, multiply that by my time of the headwind, and set that equal to the time of the tailwind. I can take and distribute through, and I get 900 over 600 minus 3W is equal to 450 over 200 plus W. Cross product once again. I take 450 times 600, which gives me 270,000. Minus 450 times 3, which is 1350. W is equal to 200 times 900, which is 180,000, plus 900W. Get all the W's to one side. Bring this guy over. I get 2250 W, and then 270,000 minus 180,000 is just 90,000. Divide by 2250, and I end up with W equaling 40 miles an hour. Okay, now this is an older problem, and they introduce it again in this chapter. I don't think it's a real good idea to use rational equations for this because it just makes the problem harder, I believe. So I'm just going to review how we went about doing this earlier, and hopefully it'll help you out and give you a little bit of review. So it says we've got 500 milliliters of a 60% solution, and we want to know how many milliliters of a 30% solution must be mixed with it to get a 50% solution. If you remember, we're doing a mixture problem, so we mix two things to get a final amount. So part 1, part 2, and then the mix. And we have percentages of silver nitrate in each. This carries 60% of silver nitrate, 30% of silver nitrate. So if we have a higher concentration, mix it with a lower concentration, we're going to lower the highest concentration down to 50%. And Joe says he's got 500 milliliters to start with of the 60% solution. We don't know how much we're mixing it with, but if we dump 500 into a vat of X amount, we end up with X plus 500. And let's just say I had 100 gallons of 50% solution of silver nitrate. Then in that 100 gallons, I'd have 50 gallons of silver nitrate. In other words, I just multiply the two together. So we take the amount, the percent, multiply together, and get the total silver nitrate. So multiplying these two across, multiply 500 by 0.6, gets me 300. Multiply 0.3 by x, get 0.3x, and then I have 0.5x plus 250. These two, once again, are going to add up to equal a total. So we have 300 plus 0.3x is equal to 0.5x plus 250. Bring the 0.3 over, get 0.2x, bring the 250 over, get 50, take and divide 50 by 0.2, and we end up with 250 is equal to x. So we add 250 milliliters in this case. And I think that's all we've got for the day. So make sure you do your Connect Ed, fill out your summary, and we'll discuss this more tomorrow.